Hello, everyone. I hope everyone can hear me okay. So I have people still kind of popping in, but I think we'll kick off in a second. Um, I think most of you probably have joined the recitation that happens just before this class. So hopefully you got a little bit of what's to come for this class, but I'm going to go through some of the logistics, some of what we hope to accomplish with this class, and then get right into it. Okay. So I see we got 31 students. I think that's good for us to get things going, and people will start to pop in a second. So welcome to CS170 for the summer session. My name is Arnold Lau. I will be teaching this summer session. And it's one of these classes that's required for your continuation with the business school. So hopefully we can make this an enjoyable experience. You can learn something and whatnot. So just to give you a quick introduction for myself, I actually am not a full-time professor. I actually have a day job. I actually work in an investment bank and working on the technology side, but do a lot of different things on the front office side of things with automated trading, looking at risk management, so on and so forth. And some of the stuff that we look at in here, notably things like Excel, is something that many of you are going to have a chance to work with as you get into your working lives. I also do other types of entrepreneurial activities and investments. And again, I'm doing different things with social media, marketing, and whatnot. So they all have some sort of tie into technology. So, kind of what I'd like to do when I teach this class is pretty much give some of my experience and tie what you're learning in class right now to things that you may be doing when you graduate from Rutgers. Okay, so that's part of my background and what I'm hoping to accomplish by being here. So, I think with the summer session with 170 and probably with all the summer classes, there's some pros and cons with the situation. Obviously, we're in a little bit of a unique situation because we're doing stuff online with the COVID situation. Hopefully, it's getting wrapped up and we'll be almost back to normal back in the fall. So one unfortunate thing is that we are running under a compressed timeline. So a lot of stuff that you'll be learning now, I've tried to shave a little bit off, but you're actually learning almost everything that you would be covering for your fall or spring semester of this class. But you're only doing it in 2 months, right? So actually less than 2 months. So not that much time, a lot of material to cover and digest. So that's probably the not so good news. But on the flip side, I would say doing stuff online, with the exams and whatnot, they're online exams. Unlike the normal class, the face-to-face class, the exams are essentially open book exams, right? So I do highly encourage you to take notes and use those notes to study for the exam and to also use during the exam. So I'll try to make a point during my lectures to point to different things that will definitely be on the exam. And, with coding or with some of these other things that's going to be on the exam, the best thing is to have examples to refer to and then use that for the exam. So, I do encourage you to do that because I think that's one of the benefits of doing stuff online is that you will be doing online exams essentially in an open book fashion. Okay. So, I think that's one of the good things about doing this stuff online, but I do warn you, it is a pretty compressed timeline. Now, some of you probably have already researched this class. I'll kind of tell you that Um, it may seem like there's a decent amount of work to get done, but I would say a very high percentage of the class does well, right? And what I mean by doing well, if I took a sample section, let's say from last semester, 90% of the students got an A or a B, right? What I would think to be a good grade. And out of those 90%, another 90% actually got A's. So you can probably do the math. A very high number of the people in this class, if you just put the effort in, you're going to get a good grade in this class, right? This is not a class that is meant to like torture you, to give you a bad grade, or whatnot, right? So this is a class, I think we do a lot of different things to make it very fair. We give you some essentially second chances. We don't weight the exams too heavily, and I'll go into that in a second. So this is a class that if you put the work in, you should get a good grade in this class. Okay, so I'll kind of go through that. Now, when you look at the way we structure the class, a lot of times people will ask me, say, can I just like watch the lectures? Can I skip recitation? Can I not read the book? No. So, each of the different aspects of the class are meant to complement each other, right? You can't just look at one thing and then forget about the other two pieces. So the way these things kind of work, if I actually covered every single thing that's in the textbook, we'd be in a lecture for like 3 hours each class or more, right? There's a lot of details that are in the textbook, which I'm not going to look at it verbatim. I'm not going to read it out to you verbatim. It's kind of up to you to take a look at some of the reading material. Having said that, I have trimmed back some of the topics because I do recognize we're trying to squeeze a lot in a small class. And then, I'll give, my lectures. I'll try to hit all the major key topics, highlight the things that are definitely going to be in the exam. And then some of the stuff I'll kind of hand it off to the recitations to go into a more detail, right? Some of the detail examples, some of the, troubleshooting and whatnot at the lower level, the recitations will be there to help you. So the recitations are fairly small. There should only be like 20, 25 people in each recitation. Probably if that, probably will be a little bit less than that for each recitation. They will be taking attendance on the recitations, but that's where you can kind of get like the more of the detailed interaction. All of the TAs and myself will have office hours, which you'll see here on this homepage. But really, if you give us enough notice, send us an email. If you have another time that works better for you to have office hours, we can go over anything you want one-on-one. Okay, so that's how all the different pieces fit together. So yeah, on the question about whether there's attendance or not, so the recitations, like I said, they will be tracking attendance. Okay, so in case you don't know, some of you, maybe this is your first class at Rutgers. So there is like a couple of things that happen. One is like a midterm warning, although like in this summer session, I don't know how you have a midterm warning, but you have a midterm warning that warns you about your attendance and warns you about your grades. So there is attendance. So the way the recitations work, the TAs, usually what they do is they'll have you fill out something. Maybe they'll have like a little easy question, a couple easy questions that they'll ask during the recitation, and then have you respond. And hopefully, that's a fairly lightweight way of like tracking attendance. For myself, and I'll get to it in a second, but we actually have extra credit, okay? And we have a discretion of how we allocate our extra credit. The way I allocate my extra credit is I'll ask, some questions. There may be some work during class. I'll ask some questions and I'll ask people to email me. So I put my email right here. You can email me. And what I'll do is you'll see, like, I'll have my email here. And at the end of the semester, what I'll do is I'll group together all of the people, I'll group it by people, and I'll use that to both really understand how many people have been looking at the recitation, not the recitation, the lectures, videos and also use that for extra credit. So I can give everyone essentially 8 points extra credit. And I'll be doing that based on people responding to the questions that I pose during class, right? They will be easy questions. And the way I try to structure the questions, again, it's really to kind of line you up to take notes for the exam. So I'll ask some questions. You'll probably want to make sure those answers are correct and then save the notes on that work that you did and use that to study and to use for your exam. So that's how I handle attendance / extra credit for myself. There's a total of 20 extra credits between myself and the TAs. Two of them will just basically be the introductory assignment. So there'll be 2 extra credit points for that. So altogether, you're essentially getting 20 extra credit points. 20 extra credit points is actually enough to move your grade by 1 level. You can get you from a B to a B+, a B+ to an A, so on and so forth. And we don't intend the extra credit to be something hard to do, right? So it behooves you to do the extra credit, right? It's almost like an easy bump up in your grade, okay? So let me kind of go through a couple of these different sections here. So, you got this stuff here, talk about what the goals it is, but, I essentially would interpret it that most people are here because it's a required class, right? So you have to take this class and, that's why you're kind of here. But, it's basically the intent of the class is to try to offer you some sort of like introduction to technology. There's no expectation that people here are computer science majors or have a super strong computer background. So, we'll try to frame things in that way. Although for some people, they may not feel that way. They might feel that, it's going pretty fast. We will try to understand and shape things, understanding that people are not computer science majors, okay? Now, this next point here, and I had to bold this and whatnot, this is really important, okay? So if you're not really familiar with these things, there are obviously resources to do things from the internet, right? But just as easy it is for people to pull things off of the internet, it's just as easy for the university with its tools to be able to scan and match whatever you submitted to something that's on the internet. So I would say don't do it, right? Because it's a tremendous pain in the butt for me to go through the admin. There's a pretty big admin process to go through academic integrity violations, right? And for you, the first violation, you get a 0, right? The second one, it gets to something pretty serious, right? And in either case, it is a mark on your record for 10 years. So I highly encourage you to not do it. And if we come to you and raise it to you, we pretty much have a smoking gun, right? There's no doubt about it. If you choose to dispute it, it just makes things a lot harder. So for a class that is so easy for you to get a good grade in, I don't really see why you want to violate the academic integrity policy. But I have to warn you because we have people trying it. And unfortunately, a class that they should have done well in, they end up, failing. Okay, so I really encourage you not to do it because it hurts you. It's not really worth it. And on my side, I have to file a whole bunch of admin work to process any academic integrity violations. So yeah, don't do it, okay? Like I said, it's very easy for us to scan your work and compare it to your classmates' work and compare it to resources that are on the internet, right? So I have to say this multiple times and repeat it probably because, like I said, even after all our warnings in past semesters, it happens. And we do follow up on it. And, unfortunately, it becomes a bad mark on your record for 10 years. Okay. All right. So, this is my contact info. I set the office hours here on Friday, 3 to 5 p.m. But like I said, if you have anything, you say you can't do Friday, you can do another day, that's fine. Just send me an email. I'm going to be sending out announcements for every Zoom class because they want me to use a different Zoom link for every lecture for Zoom bombing and all that kind of stuff. So I will send it on announcements, right? Canvas announcements. So do pay attention to that. I've asked the TAs not to send out too many announcements, so you won't feel like we're flooding you with announcements. So, do pay attention to the announcements that we do put out. Okay, so I will be putting out announcements before class to give you the Zoom ID and password to log in. Okay, these are the recitations, 4:55 to 5:50. Now note, I'm saying 6 o'clock to 8 o'clock, but I know it's like horrible to kind of sit in a lecture for 2 hours, right? So I will try to give some breaks in between, get up, walk around, grab a coffee, do whatever. What I might do is essentially part of attendance. I might make it like 10 minutes, 15 minutes, but then I might give you like a little quick assignment, whatever, right? Just answer a couple of quick questions, submit it, send me an email with it. So you're kind of doing something. It's almost like in-class work, right? It helps me with my attendance, helps me to give you extra credit, and helps for me to provide some breaks during the class. I will try and do that so you're not sitting there for 2 hours straight. I know, I've been on the receiving end of those things. It's not great. So I will try to provide a couple of breaks in between throughout the lecture. Okay. Most of you have probably gone to recitations already, so you know these two here. Most of you should know which sections you belong to, but if you don't, send me an email and I will look up your section for you. Whatever section you're assigned to, that's where your grades come from, right? So your TA is going to be grading you based on your recitation, and they'll be actually doing your grading for your exams and all your assignments, right? So you could go to the other TA if for whatever reason they're both at the same time. Then it's something that you need to let them know that's what you're going to do, because if you don't do that, then one TA is going to think you haven't been showing up to class, and it's not going to be good, right? So do try to show up to your recitation, but if for some strange reason you want to use the other TA, you have to let the both of them know, okay? Here you have like the info about the WebEx. Guangyang likes to use Zoom. I like to use Zoom. My office hours, I'll use WebEx. Here's their email, and then they'll have like the recorded recitations here, which is, so here's an example here. So you have all the dates, you have a link. So they recorded these recitations. I actually am recording, but again, I don't know how it's going to turn out to do like a 2-hour like Zoom recording. So what I did was here in the media gallery, I actually took my last semester's video clips. And what I did for last semester, I actually essentially did short video clips. They're like 5, 10, 15 minutes maybe. And they cover different topics. So I will record the full length lecture of what I'm doing here, but I'll also have last semester's topical video. So you can choose whichever ones you want to go to. So it's under media gallery. You can go to that. And I only have up to week 4, but I'll put the rest of the weeks in there. These weeks are weeks in the spring semester, right? So obviously, since we compressed it for the summer semester, some of these weeks won't necessarily line up, but you should be able to follow along by looking at these chapters and stuff like that, okay? I noticed someone just sent me something in Canvas. Try not to do stuff in Canvas email, because most of the time, at least the TAs that I know, they're going to be using the Outlook. Okay, so try to use Outlook for your email contact rather than the Canvas mail, because people might just miss it. Okay, so let me go back to here, go back to home. So that's the recitations. Here's the course syllabus. So you can kind of preview it here. And let me just kind of scroll down, see. So you can see here, there's all kinds of stuff in the syllabus you should kind of take a look at. I'm not going to go through every single detail, but here's a couple of things. Obviously today's Wednesday, June 2nd. Here's the exams. So take a look at that. So if anyone has any conflict with these dates, let me know sooner rather than later, or anything, right? If there's anything where you can't attend class, you can't, do the exam, whatever, it always helps you if you let us know sooner rather than later, okay? And I'm going to get into the assignments in a second. There's like the assignments and whatnot, and we have a late assignment thing and whatnot. I'll go into that in a second, okay? So you can see here, self-reporting absence application, okay? So yeah, so the question, I see a question here about like the materials. So I'm going to show that to you in the section, what is covered for this week, okay? Academic integrity again, the Canvas tools. Notable thing is the announcements. Pay attention to the announcements. The assignments tool, I'll go over the assignments in a second. The grades, the syllabus, not too much to worry about here. Here's the book, okay? The suggestion is to get the electronic version. It's much cheaper than the hardcover book, or even the softcover book, right? So just get this. It's fairly reasonable. I put it on the homepage up here. So you can see vital source. You can see it here, and you can see $24.99, right? I forgot what the hardcover or the soft cover looks like, but it's much more than that. So yeah, I would suggest to get this one. Okay, so you go into vital source, just get it, and then you're good to go. Okay, and then I have that here. Your recitations, your TA is going to be going through like the Office setup. Every student has access to Office, so you'll be able to get the latest version for free. So I would encourage that. This is for drawing diagrams, flow charts. You're using Chrome or Firefox. Each of the TAs has their own preference on the editors. I'm kind of okay with Notepad++, but it requires a couple extra steps in terms of like doing stuff from the HTML in the browser and whatnot. So some other people might do things like Atom. There's JSDO, Codecast. You don't have to worry about that for now. I'll go into these different things when we get to them. At the beginning of class, you don't have to worry about it, okay? There's a question about whether the 6th edition will be acceptable. I think it's fine. You should be able to, the material is more or less the same. Sometimes the questions are a little bit different, but nothing major, okay? So that's this. So you can click on it here and you'll get that. This is resources, right? So what I'll do is I'll kind of post things into here. It's not here right now, but each week I'll try to put in some resources. And it could be like YouTube links or whatever, so you can get extra guidance on some of the work. Okay. This is the schedule. It's just a little bit small. Let me get the bigger version here. So this is the summer schedule. So what we tried to do is line it up by week. So here we're in the first week, and what you'll see is some of the major topics, mostly here. In the book, it's chapter 2 and 7, okay? And like during your recitation, basically they'll be giving you some introduction stuff for Canvas basics. And this is the extra credit assignment, which I mentioned, okay? This is when we post it. This is when it should be available. And then the due date is June 13th, right? And in this case, there's no free late, okay? So what free late means is that whatever your due date is, if you, you can see like, here's the due date of the 20th, let's say for this assignment, and then it has an accept until the 27th. Well, yeah, we can accept it until the 27th, but you're only going to get half credit for it, okay? So a free late Now you can't like do a free late like after you've already missed your due date. So sometime before the due date, you can say, hey, I'm not going to be able to make this due date. You have to let your TA know. You can CC me, I guess, and you'll be able to turn it in until the accept until date for full credit. Okay, it'll be graded off of full credit there. So that's what the free late is. You get one free late, but the first assignment, the introductory assignment, the free late doesn't apply. Okay. You can see here, here's the exams here, right? Let me make this a little bit bigger, I guess, right? So you can see the exams here. The hourly exam 1, 2, you got the date and the timing for it. So we'll send out like the information for it as the time gets closer. We'll have some sample questions and whatnot. These are your assignments, right? Here's the scores for them, right? This is the extra credit here, okay? And it kind of totals up to 520 up here. 500 is really what the points are, right? 20 points are the extra credit, okay? And then we'll have some grading based off of that, okay? Now, some people are gonna go look at these averages within the Canvas and like get all freaked out if the grades are all over the place. So there's a reason why the grades are not quite accurate on Canvas for the final average grade until the final exam is done. So we have this thing called a second chance policy, which to get to the second chance policy, it's basically juggling around grades between your exam 1 and your final exam section. So at certain periods of time, you actually have a 0 in there. So your average gets kind of pulled down a bit. So don't freak out if your average is like not quite there. You know, it will get fixed by the time we submit, by the time we process the final exam. Okay, so probably like from here to about here, your grades will probably look okay. Once we get past the exam 2, that's when your grades start, your grade average starts to look a little bit weird in Canvas. So don't freak out when you see that. Let me go back to here. Go back to, I think I thought I had the percentages here. Yeah, so you have the percentages here, right? So you have the hourly exams, your final exam, your assignments, and then your extra credit, right? So just going by these points, you can see like your assignments far outweigh your exams. Okay, and that was done intentionally. It actually used to be the other way around. Your exams used to count way more than your assignments. But ever since we had to go online, we've kind of flipped it around so that, you know, your exams are not so high pressure. Okay, so you know, you do your best for the exam, and that's it. But if you really put your mind to it, you do your assignments, you pretty much should get a good grade in this class, right? So that's the intent of why we weighted it this way. Okay, and so that's where the percentages will come in, and you can see how they translate based on these points. Okay. So I think I answered like what was the question about what will be covered this week. So that was in here. Okay. So again, here's the office hours. So I showed that to you before. And course objectives. This is pretty much a good guide as to what will be in there. On each of my lectures, I'll actually have some highlights in there also. You can see I put some red lines through some of the stuff, which essentially means I'm going to de-emphasize these points and not talk about them too much for the exams. So what I do have left are things that you should be studying, and make sure you know what they are because they will be on the exam. Okay. And when we have these things here where it says text questions to complete, this is not text questions to complete to turn in as an assignment. It's more for your own self-study. Okay, so take a look at it. If there's things in there that, I mean, hopefully, I think these questions and answers should be fairly straightforward, but if there's things in there that you're stuck on, that you don't know, then raise it up to the TA or to myself, and we'll try to get you sorted on those things. Okay. So you can see here, you got chapter 2, 7 and 8. This is based on the normal fall and spring weekly schedule, but the content is the same. Okay, so I crossed off in red some of these things that I'm not going to include in the exam, but these other things are fair game. Okay, so I tried to trim as much as I could without like really distorting the nature of this class. Okay, if I look at it at a high level, probably the main things that we want to get out of the 3 different sections for this class, the first section will basically be things like HTML, numeric conversions, and then the second section is mainly JavaScript, and then the final section is basically Excel. Okay, so that's how I would frame it as the major topics. And then there's some other complementary topics on these things. So what I'm just scrolling through here is basically what will be in the exam 1, right? So exam 1 material, okay? And then you can see likewise for part 2 and part 3, okay? And then you have the Microsoft Office for students here. Now, the other thing is when you look at the second chance policy, not the free late policy, the second chance policy, this is the idea where, let's say you took the exam 1, you didn't do so hot. The exam 1 of the final exam will match up in terms of content that it's testing to the exam 1. Okay, if that part 1 of the final exam you do better than the exam 1, you will get that score applied to the first exam, right? So let's say you got like a 50 or something on the first exam, and then you got like a 75 on your part 1 of your final exam. We will take that 75 and use that 75 for the exam 1 score. Okay, so you'll basically have a second chance to improve that. And likewise for exam 2, that will correspond to part 2 of the final exam. And then like the part 3 of the final exam, you don't get a second chance policy. That's just like the last part of the class. So that's how the second chance policy works. Now it doesn't work the other way around. So it doesn't mean that you got a great score in exam 1 that you don't do anything for the part 1 of the final exam, and then that score moves forward. It doesn't work that way. It only goes one way. Okay, so hopefully that second chance policy, you get it, but if you don't worry about it. We're going to talk more about it when the time comes closer. Okay, so hopefully that covered the major stuff here. Okay, so I guess I have a question here from Charles. Charles, if you like to speak.
Oh, sorry. Can you hear me?
Yeah, I can hear you.
Oh, sorry, my mic was muted. So does that apply to both? So say you do poorly on exam 1 and exam 2, but
Yep.
then you nail the final. Will you replace both grades or only one of them?
Both grades.
Oh, wow. Okay.
Okay. So yeah, like I said, I think we try to give you every opportunity to do well in this class. So whether it's like the free late policy on the assignments or the second chance policy on the part 1 and part 2, exam 1, exam 2. So you do those things, you're going to get a good grade in this class, right? So like I said at the beginning, 90% of the kids in this class is going to get a good grade, right? It's either A or B. And out of those, 90% of people get A's. Actually, most of the people that end up failing were the ones that got caught cheating, right? So, if you're not cheating and you do your work, you're going to get a good grade pretty much, right? So, so that's the story. But, look, I understand when people have like some challenging issues, like medical issues or whatever. I think it's a general university policy. You go to your dean, you get your medical excuse, doctors know it or whatever, and then just send it in and we'll work with you, right? We'll work something out. I can't give you like a general answer as to like what we do, but we do try to accommodate people. But you do have to try to work with us and get us that heads up sooner rather than later. Okay, so that's the main thing there. So here on assignments, okay, you'll see we already have all the assignments lined up. exams and whatnot, right? They're not visible to you yet, so don't go looking for it. This is the instructor view here, right? But I just want to kind of show it to you, like we've kind of got everything lined up, and what happens is like you see these dates here. That's when these things become visible to the class. So you can see all that here. So everything's kind of set up, ready to go. It's ready, it's locked and loaded, ready to fire, right? And you can see how these percentages work out. So don't like get too worked up on the points, although I put the points on the syllabus. I tried to match up the points to match up to these percentages, but they may not 100% match up. So these are like the way the percentages are supposed to work out to calculate into your final grade. And you can see you have these exams, the high exams and whatnot. That's why your grade calculation gets a little funky towards the end. Okay. So that covers like all of the basic introductory stuff. And so I already have my PowerPoints loaded up here, but like I said, there's a 2-hour thing. So I'd like to give everybody like, let's say a 5-minute break. So go ahead, a 5-minute break, bathroom break, coffee break, or whatever. And why don't we come back here in 5 minutes? I'm going to leave the Zoom up, but yeah, go take a break. We'll be back in 5 minutes. I'm going to kick off with the lectures. Okay. All right. Thank you. Okay, hi. Uh, I think I'm about 5 minutes here. I should have made a note about what time I let you guys out at, but I thought I did it at 6:36, so 6:41 should be good. Um, so I'm gonna start off here with chapter 2. Okay. Um, as I said before, I'm going to have these on short video clips on the Canvas also. That's really from the spring semester. It will be in the longer Zoom video that I'm going to post up, but this kind of just saves you the trouble of like kind of, clicking to wherever it is on the video to find out about the topic that you're looking for. Um, and I'm going to post these PowerPoints into my resources also. So you'll be able to click on week 1, you'll see the PowerPoints and whatnot. Actually, I have to save them as PDFs, but it should be the same thing, okay? So, um, so chapter 2 is basically talking about how we interface with computers, right? So human-computer interface. And there's some things that have developed over time. Obviously, computers have been around for a long time, but back however many years ago, it was very focused to a small group of people, maybe academics, maybe engineers or whatnot. And over time, notably through things like the internet, it's gotten wider and wider. I would say democratization, right? So more and more people can do things with technology. So you don't have to have like a specialized computer science degree. You don't have to be an engineer or whatever. You can easily use it, right? I mean, you look at things like an iPad or whatever, the fact that you could have like, a toddler or a preschool kid pick it up and know what to do with it, is really kind of showing how far things have gone, right? Like, back, maybe what in the 70s or 80s, there's no way you would be doing stuff like that. You would need to have like however many years of training to be able to do stuff with the type of computers they had back then. So that all comes down to like how the human computer interface has changed over the years. Okay. So yeah, all of the stuff that I just mentioned, these are the things that essentially have brought like computers into like more of a consumer type of product, as opposed to before it was more of an engineering computer science person. Okay. Uh, so let me see here. Yeah, so good, bad, and ugly. I think probably most of us like these days, like the interfaces are pretty mature. Like people are used to seeing things like Amazon and whatever. And you have pretty decent interfaces, right? It's come a long way. Okay. So there's this idea of the user experience. Okay. This is not the same thing as user interface. So user experience is like the overall experience of something, versus the user interface would be like, me clicking on a particular button, let's say. Okay. And I'll try to kind of, break that down a little bit here. So this is the user experience. You can see like this little Venn diagram, like how these things all come together. And then you have the UX like right here in the middle here. Okay. So you have the look, the usability, and the feel, right? And usually what I do at this point is I kind of draw the attention to something like Amazon, right? And even where Amazon is right now, it's not something that's been constant over time. If you ever interface with Amazon from like near the beginning, like many years ago to where it is now, that interface has evolved, right? But you can think of like, how does Amazon make things so easy for you to buy something, right? And maybe people have not experienced a bad interface to understand the difference, but Amazon does a lot of different things, from like the one thing that they're kind of known for from the early days was like the whole one click, right? So you don't have to do anything, everything's stored in the system. You see something you like, you just click on it, and one click you buy it, right? You don't have to worry about typing in your address, your payment info, nothing. You just say, I want that thing, and then it's on its way over to your house. So the user experience, you don't really feel like uncomfortable. You don't feel like it's a difficult pain in the butt to try to do something. it just kind of, makes it happen, right? So that overall experience is user experience. And there's people that actually go to school and get trained, especially to design a great user experience, right? And that type of thing as evolves as the different types of devices that we have access to become available, right? So, until more recently, there wasn't so much things that you can do on a mobile phone or a cell phone, right? But as they've gotten more powerful, you can do more and more. And practically now you can do almost everything from a consumer perspective on a phone, right? And so that's taken like a lot of investment in terms of like both the hardware, but also on the software side to make the user experience really good, okay? So what are the different things that go into a good user experience, right? There's this idea of a feedback, and I'll go to that in a second. And then there's a consistent interface. And then perfect reproduction, I wouldn't say that's part of user experience, but that's another topic that we're covering here. So feedback, you could imagine like back in the old days, I would do something. Let's say I make a request. Let's say I'm with my bank, right? And I put in something to deposit my money, okay? And you click a button to say, let's say deposit, and let's say it takes a long time for whatever reason, but you get nothing. Nothing will come back. You don't know whether your deposit worked. You don't know how much money you deposited, like nothing, right? So feedback would be something like, oh, there'll be like a little bar that's kind of showing that, we're sending your transaction. We saved your transaction and you deposited $100 in XYZ account or whatever, right? That's like feedback, right? Without that, you're not clear what happened. Did the transaction actually happen? Did it fail? Did it put in the right amount? Did it put it into the right account? All that type of stuff. So there's this idea of feedback, right? And normally when you look at, let's say, a Microsoft product, let's say something is kind of like taking a while to process, you might see an hourglass, right? That's okay. That's better than nothing. It's better than just showing you a regular mouse button. But if it gives you like a little feedback bar that kind of says, oh, this thing's going to take like 2 minutes and, you have like 30 seconds left before it will finish, that tends to like make people feel better about the user experience when I tell you, how much more there is to go to get something done. Okay. And then consistent interface, that's something where you have like, let's say Microsoft Office, right? There's a lot of different things here that, at the top, you'll do kind of the same thing, right? So you have this thing on the left, you can do file, you can do a new for a new version. Like if I do this in PowerPoint, it's a new PowerPoint, right? But if I did this in Word, it would become a new Word document, so on and so forth. So like all of this behavior is consistent, right? Is what they call consistent interface, okay? If I do an insert, you have different things you can insert. You'll have things that you can do from a formatting perspective, whatever. Like as much as they can, they try to make things work consistently in a certain fashion, right? If I do stuff on a browser versus somebody's desktop apps, if I want to do a find and search or replace, they all kind of try as much as they can to be consistent, right? So you learn one thing and then you can do it on other things easily. Okay, that's the idea of having a consistent interface. Again, that improves on your user experience. So I just talked about this with the feedback, right? So you can have this, right? So you have the cursor replaced by, let's say, what I was talking about before with the hourglass. Then you have like the little thing like this, right? You have like this little smiley face, looks good, right? You might have a sound, you might have an email that comes back to you. The progress bar that I was talking about before tells you how much time is left, how much file that you sent over, at the rate it's going. All of this is like feedback, okay? Consistent interface. So like what I was saying before, you can do things like file and edit. a lot of you do things with, various editors, we cut, copy, and paste, right? All the same type of thing. It behaves the same. There's no reason for each of the applications to do it in a different way. So overall, everyone kind of agrees to a certain standard or best practice on these type of things, right? It doesn't really benefit anyone to do it in a different way, okay? So like I was saying, Microsoft, all of the Office stuff, right? So it's the Word, Excel, PowerPoint, almost all of them will have pretty much like for like everything, file, edit, and whatnot. So these are the benefits that you get out of the consistent interface, right? One, from a company standing, they'll be using pretty much the same code, right? So there's certain things like, let's say the toolbar, that will be the same code essentially across all of these, okay? It helps you as a user to be able to pick up and use the application very quickly, right? If you learn like one, you can do all the others fairly easily, right? Because you're just used to the way things work. See, it's just like fundamental processing. And so all the apps would just use the same thing, right? Saving a file, right? Creating a new one, okay? And then you just have a sense of familiarity from using the application, okay? So this is like an old interface. This is like with the, essentially with the, I guess, probably before a lot of you were born, right? So 1990. So you're basically punching in like these numbers here. It'll be like, let's say you want to use user tasks, right? You're going to probably put like a 1 here or something like that. There's some other types of things. You can use these function keys and whatnot. So these are, essentially what they call command line interface. Okay, so you're basically typing things at this command line right here. Okay, then you get into doing what they call a graphical user interface, right? So you have this, right? So this is one thing that I think a lot of people gonna get caught up on. Like the book kind of talks about it. It kind of flows through to the exam. So Apple basically bought this out basically as a consumer product. So they introduced it with their products, but they were not the people who invented this, right? So Xerox is the first one that came up with the graphical user interface, but Xerox didn't become a consumer company in the way Apple did, right? So Apple basically got access to this and incorporated that into their products and made it a consumer product. So everyone thinks of the GUI as an Apple thing, but really, and there's a distinction on this. So, who invented it versus who brought it out to the open market, right? And really sold it as a consumer product. And most people look at it because they know Apple, they know about the graphical user interface, they assume that Apple invented it when they did it, okay? So this is an important distinction. You may get this on the exam, right? So something you want to make a note of, okay? All right, so the idea of reproduction, not really sure like that has anything to do with like human computer interface per se, but one of the great things about doing things digitally is that you can make perfect copies of stuff, okay? So if you look at any of the old analog ways that we used to store information, whether it's music or whatever, you store stuff on like old videotapes, on records or whatever, just because of the medium, over time, it will degrade. You make more and more copies of it. Each copy you make of it gets a little bit less of a perfect reproduction, right? Or less, a lower quality reproduction, right? Versus if you look at things, we'll cover in the next one, everything is zeros and ones. When everything is digital, everything is zeros and ones. You're just copying zeros and ones, okay? So you'll be able to look at a picture and you won't be able to tell the difference between one picture and the next picture because it's a perfect reproduction, okay? Versus like if you took like your old photographs or something, or something that was stored on film, every time you make a copy of it, it just gets worse and worse. Okay. So this is basically what I was just talking about here, right? So it stores everything in terms of zeros and ones, the computer. And then if you just want to copy that perfectly, you're just going to copy those zeros and ones. Okay. Okay, so that's what this is meant to show, right? This one and that one, same thing. Okay. And then, find and replace. This is just like one of those type of things that's a very common type of function. So again, this goes back to the consistent interface here. So that's this probably should have been further up in the PowerPoint, but that's here, right? So find and replace is another one of those consistent interface type of things. So this is just a check, right? Like what I was saying, like what is a UI versus UX, right? UI, that's like physically like on the screen, a button or whatever that I click on. And then the UX is the overall experience. And then perfect reproduction, right? Remember that for analog, each subsequent copy is going to degrade, right? And a digital, you can make a perfect copy of it every time. It's only zeros and ones. Okay. So what's the purpose of computers displaying progress bars? As I mentioned earlier in the lecture, it's about feedback, right? Show you that there's some progress and show you that there's how much X amount of time left to get something done, let's say. Yeah, so which company introduced the mouse? Don't have to worry about this one. This is something we normally teach in the class, but I am taking out the metaphor, so you don't have to worry about this. Let me just delete it right now. Okay. And know what the advantages are for a consistent interface. There's a consistent interface benefit for the company that's making the software, and there's a consistent interface benefit for a consumer who doesn't have to learn how to work on something every single time they come up with a new application, right? Everything will work the same, okay? So make a note of that for your notes there. And then that will be chapter 2, okay? And I made some notes here. You have the feedback, perfect reproduction, copy and pasting, UX versus UI, and then overall GUI, and note the difference between Xerox and Apple with respect to graphical user interface, okay? So I think I'm feeling pretty good about going to the next one. I know, I wanted to give you a break, but I think everyone seems to be okay here. But let me know if there's any challenges. So we're on the chapter 7, digital information. Normally this is actually in our second week, not in our first week, but with the compression, we're going to be doing this. Okay. So like I mentioned in the last PowerPoint, we're talking about information that's stored in terms of zeros and ones. Okay. Yeah, so these slides will be up on Canvas. I'll put them up under resources under my page after I get done with this lecture. Okay. So, basically everything can be represented zeros and ones, and I'll show you that when we do some number conversions. Okay. And then there's this idea of abstraction, right? You can see like there's two people looking at something. One person is looking at a fairly low level, another person is looking at the high level, right? And abstraction is actually a pretty important concept in computer science, but actually, all throughout life, we have abstraction, right? So I'll give you an example. Like I get in a car and I either steer the car or I step on the brake for the car, right? The fact that, maybe the car is a drive-by-wire, or the fact that I have like certain types of brakes or whatever, I don't really care. I just want the car to stop when I step on the brake. I want the car to go left when I turn the steering wheel. I want the car to turn right. And so, you don't have to be like a mechanic or automotive engineer to understand how to drive a car properly. By the same token, when you work on a computer, you don't need to know what the computer architecture is. You don't need to know like what type of chip it's running, how much memory it has, or whatever. For most part, you just know that you can go on the computer and type an email or play a game or whatever, and that's it. So that's a level of abstraction, right? You don't need to understand the underlying implementation to use the product. Okay, so whether it's driving a car, turning a car, or using a computer, right? So that's where this abstraction comes in. You you work at the level of granularity that's appropriate for your usage, right? If you're a consumer, you're probably at a very high level, right? If you're an engineer, you're probably at a low level, right? So it depends on what your level is. And, for most people, we're probably not working at machine language. We're probably not working at the computer code level, but there are some people who will be working at that level, right? And so that's the level that they'll look at. They will not be, working at the very high level because you don't see what's happening inside. Okay, so that's what abstraction is about, right? Giving you the right level of information. So, they kind of phrase it as removing complexity, hiding complexity. Okay, so if you want to look at a map, right, depending on what you're trying to do, right, maybe for some of us, we don't need to look at this level of detail, right? I don't really care too much about these individual houses over here or whatever, right? I care about finding some parking, right? So here's some parking here, right? And you can kind of just look at the major street here and say, here's the parking here, right? So in some cases, you might not even have like all these different street names here and whatnot, right? So it depends on what your usage is. But it's about hiding complexity is the basic idea for abstraction. Okay. So algorithm, this is kind of setting you up for being able to write some code, right? Code is basically implementing the idea of algorithm, right? So you have something to do it. The analogy I would draw to is like a cookbook, a recipe, right? So you want to make a cake, then here's all the different ingredients. This is how you put those ingredients together. And then if you do everything right, out comes a cake, right? So that's what algorithms are. And, like I said, algorithms, that's really in the context of eventually you will write some computer programs to follow some steps, okay, or algorithms, okay? And we'll be doing that as one of our assignments, okay? So P&A, presence and absence, right? 0 and 1. So anything that's essentially binary, right? So everything that can be done as binary can be representing, let's say, digital information, okay? Off and on, black and white, in this case, presence and absence, and whatnot. And we're gonna go into that in a second. So I'm gonna try to do some of these here, but I'm not gonna go into super detail with this. For your recitation for next week, you will be having more examples for these conversions. This is a big topic here, conversions. So it's kind of mechanical once you see some of the examples, but it tends to give some people some problems. So we'll try to spend more time with this in the recitations for these conversions, okay? On the ASCII topic, I'm not really going to spend a whole bunch of time or test you too much. All you really need to know is like, if I have one code here, if I want to map from one thing to another, I might give you a table and say, okay, if I give you A, that means like, apple, right? If I give you a B, that means, boy or something like that. So it's like taking one thing and mapping it to something else, right? That's kind of the general idea. So if I give you an ASCII table, or I give you an extended ASCII table, or I give you Unicode, it doesn't really matter. To me, it's just like, you being able to look at one thing and map it to something else, right? So although I'm not going to talk about ASCII or extended ASCII or Unicode too much, it's still fair game for me to give you a table and map it from one value to another value. That's a more generic way of looking at it. So I will be doing it that way. although I'm not going to specifically talk about ASCII, extended ASCII, or Unicode. I'll tell you what it is, but you don't have to study too much about it, okay? And then metadata, okay? So P&A, again, like I said, it's presence and absence, okay? It's what is meant to be the idea of discrete, okay? As they say here, no shades of gray. So I'm gonna draw like an example here. So you can imagine the idea of 0 and 1. 0 and 1 is basically your two values, right? So that's discrete, right? But if I tell you like all the values between 0 and 1, like 0.1 or 0.11, right? Or 0.111, right? Essentially, it goes out to like infinity, right? So the more decimal places you go out, the more type of numbers you can get between 0 and 1, right? So when we talk about things being discrete, we talk about like, this whole presence and absence, binary, no shades of gray. That's what that means, right? So whatever it is, like I said before, you can do black and white, you can do off and on, 0 and 1, stuff like that. That's what all of this comes down to. And really the language of computers is 0 and 1. Okay, it's binary language. Okay. So yeah, here you go, right? All of this stuff here. That's all binary with me. Okay. So this goes into like bits in computer memory, right? Just from historical reasons, legacy reasons, there's this whole idea of like bits and bytes, right? So a bit is something that could be a 0 and a 1, right? And then 8 bits equals to a byte, okay? A byte is BYTE, so that's like a quote unquote a word, right? And then as time has gone on, like these words have gotten bigger and bigger, right? It could be 8, or it could be 16, or it could be 32, 64, 128, 256. So these are kind of groups of bits. And they're forming words from a computer perspective, okay? So this kind of talks about the binary system. I'm going to do something on an Excel sheet to kind of cover this a little bit, okay? So hex, explain what hex is. It's really kind of almost for human consumption, right? Because a computer doesn't care. A computer, as far as it's concerned, if you show everything zeros and ones, it's fine, right? But a human looks at it, zeros and ones, like their head will explode, right? So, so what they'll do is like, like I was saying, like those bits will combine into words of bytes, right? So it could be 8 bits into a byte, or it could be 16, 32, 64, 128, so on and so forth. So with hex, they basically created this like base 16 to basically do these type of groupings so that you have less of this like gobbledygook zeros and ones to look at. And I'll kind of show that to you in a second here. Okay. So yeah, let me put a hold on this for a second. Yeah, I want to spend more time on binary before I go into hex, but yeah, where's yeah, here we go. Okay, so we have the decimal versus binary. So everybody knows decimal, right? So that's your base 10. That's easy, right? And then here's your binary, right? So here's a thing where you have like these ones and zeros and ones, and this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 4, 2 cubed, I should say. And you have a 1 in each of these slots and you add them together, right? So if I have an Excel spreadsheet, I kind of put this together already here. So this is what I did. So this is your exponent, right? So 2 to the 0, 1, like that, okay? And then you can see I did 2, and that little caret is your exponent I'm referring to here, right? And that's how you get, if you're like in computer science, this is like a very common sequence of numbers here, like these bases that go up like this. And then this is like my binary number, let's say, okay? So I basically matched up to this example here, okay? And so everywhere that I have a one, basically, I'm basically taking this times this, right? So if it becomes a zero, obviously it becomes a zero, right? So one times this equals to one times this equals to two, so on and so forth, right? And then I add them all together to get 231. So that's how this works, okay? And this kind of talks about it more here, right? So you start off with a number 231 as your base 10. And then I set up this table here, like basically all of your exponents for 2. And then I put in these numbers here and I add them all together, and that will get you to 231. Okay, and how do you get to this number? I mean, you could like take some guesses, or there's like a process to do it, right? So you can say, well, okay, here's 231. Let me start with the highest number here. In this case, it's 128. Right, the next number after 128 is 256. So 256 is bigger than 231, so you're not going to do that. So 128 is the biggest number without going over 231. So you put a 1 in here, okay? And then you subtract that, and then you say, well, what's the next biggest number? Oh, well, I can do a 64, right? So you can see, like, let's say I took the 128 and the 64 together, right? That still leaves me some room. That's why I can still stick these other numbers. So you start from the biggest number that you can fit in, and then you kind of work your way down, right? Until you eventually come up with these series of numbers that when you add them all together, they equal to 231, okay? So it's like this, they'll refer to it when you look at, I'll give you some material. It's kind of called the remainders way of calculating, of coming up with the 231 to convert it to a binary number. Now, if I give you the binary number, it's actually pretty easy, right? It's just basically what I did in the Excel sheet, right? So you can see, if I change this, let's say I put a 1 here, right? Then right away, this became 239, right? So going from binary to base 10 is pretty easy. I can just put a 0 here, right? So it's a matter of like, just 1 times any of these exponents here, and then adding all the numbers together, and magically you'll have your base 10, right? Going from base 10 to binary, it's like I said, I'm not going to do it just a second, but it's talking about taking the remainders after you divide each of these into this number. In this case, it's 231, okay? So there's a little bit of a taste of the binary and decimal conversion. Like I said, your TAs are going to go into this much more detail for your recitation. Yeah, so for binary, it's always off of exponents of 2, okay? There's a reason why I did this before I did hex, right? So theoretically, you could do the same thing with hex, which is base 16. So instead of 2 to the 0, 2 to the 1, 2 to the 2, 2 cubed, and stuff like that, you would do 16 to the 0, 16 to the 1, 16 square, 16 cubed. It's just a different base, right? So you could do base 2, which will be binary, base 16, which is hex, okay? But there's, like I said, there's a reason why I did this first before I did the hex. So let me get to the hex now. Yeah, so I'm not sure why we have the hex here before the binary. So you could do exactly what I just said. You could use base 16, but I find it actually a little bit easier to do it like this. So you remember what I said, basically hex is a way to group up the binary numbers. In this case, groups of 4, right? So you can see 4 zeros obviously equals to 0 in hex, right? And then you have, this 3 zeros and a 1, that becomes a 1, okay? So this, and then you run out of digits here when you get to 9. That's why you have A, B, C, D, E, F, okay? So like 111 in base 10, that will be 15, Okay. And then for F is your hex version of it. Okay. So you, the easiest thing from my standpoint to go from hex to binary is to group in groups of 4 and then convert it just using like this table here. You can either copy this table or you can just, it's easy for you to just write this table yourself, right? Because you're just going from 0 through 9, A, B, C, D, E, F, and then doing one increment for each of the binaries, right? And then you can kind of map it. Now, if I had, let's say, 9F, right? So if I had 9 and F, that's my hex number. If I told you to give me the binary version of it, then you just have to give me 1001 and 1111. Okay.
This stuff is not for me.
Okay. So your opinion is duly noted. All right. So so that's basically looking at hex conversions to binary and binary to hex. All right. So you can do like the base 16, or you can use like this mapping table to do this type of conversions here. And we'll go through some of those examples in the recitations also. Okay. So digitizing text, these are the different types of things that you would digitize, right? So you have uppercase letters, lowercase letters, you have numbers, you have some punctuation, so on and so forth. And then you have the ASCII standard. So, all you have to really know for ASCII is just to say that it's a mapping to map the binary characters, or could be hex, to like all of the standard characters on your keyboard. Okay, and because your computer is not going to store A, B, C, D, E, F, it's going to be storing in zeros and ones, a sequence of zeros and ones. Okay, so you're just going to apply this mapping. If I gave you a mapping table, if let's say I gave you 4 zeros, let's say, and that map to A, let's say, that's all you have to do. It's just say, okay, 4 zeros equals to an A. Okay. So, but other than that, you don't have to know too much more about ASCII. So, but here's like all of the different mappings for standard ASCII. In case some of you might know this, like looking at octal also, that's base 8. You don't have to know that for this class. Like I said, I'm not going to really try to test you, on this, but it's just a table. You can recognize it. If I were to give you this table, all you have to do is say, oh, what's this number? 40 equals to this. Okay. And these are your standard here. You don't have to know this stuff on the left here. That's all there is to this table. It's just a mapping table. Okay. So you have 85 and U, let's say. This is capital letters. These are lowercase letters here. Okay. So they call this data encoding, whatever. To me, it's just mapping. Okay. So you might start off with hello, right? That's what you would recognize as human readable. And then this is hex, right? So this is your ASCII mapping to hex. And then this is mapping to machine language or binary. So this is what your computer is actually storing. Okay, so it's just showing you the different levels of mapping. This would be human readable. This would be sort of human readable, right? Just mapping here to here. And then this would be machine readable here. Okay. And you can look these up here. And you should be able to map it out. So you have here H, and you can see the 48 here under hex. And likewise, you can do it for each of these here. Okay. Unicode, just know that it's an extended version of ASCII. It covers more characters, that's all, right? So it's just a bigger mapping table. It's really to account for different languages other than English. Okay. This is just a repeat of before, like the binary to hex conversion, and here's a decimal mapping to it. You might just want to keep a copy of this table here to do your mappings between your decimal, hex, and binary. Okay. I mean, obviously, when we do the binary and decimal conversions, we'll use bigger numbers than what's on this table. But a lot of times, if you're going between this to hex to binary, you can kind of use this and use this table. Okay. So I find that's the easiest way to work with the hex conversions, but you may choose to use this base conversion like I'm showing here. Okay. So this is converting to decimal. Okay. This is where, like I was saying before, you basically take all of these different numbers and then add them together. Okay. So in this case, you have the 64 here and the 8 over here to get it to 72. Okay. So this is what I was referring to as the remainders. Okay. I'm going to do this one here. So you take the 72, you divide it by 2, which is 36, and you have a remainder of 0. And you continue on as you get smaller. So you take this 36 and move it down to here, divided by 2, 18, you have 0, and so on and so forth. And then you kind of just say, like these 1, 0, 0, 1, 0, 0, 0, that falls to the right, right? And that's how you get this here. Okay. So that's a remainders way of converting from your decimal to your binary in this case. Okay. I'm going through this kind of quickly. We can, break it down some more if people are having questions with this. Like I said, in more detailed example, the recitations are going to go through this also. Okay. So I guess this is coming to a point where people can kind of work on some stuff. As part of, like, let's say whatever you would like to submit as extra credit or in-class work, I'm going to give everyone kind of a chance to work on this a little bit. You don't have to fill in all of these, just do the best you can. Fill in a couple of these and you can fill in the rest in your own free time. So let's just take a few minutes and try to do some of these conversions here as best you can. And then we'll come back to this. Okay, so I'm going to step away. You have like, I'm going to give you like 10 minutes or so to work on this. Yes, hexadecimal will always be base 16. Yeah, you can send me your answer through email just as part of her attendance today, but don't feel like you have to finish all of these boxes for in class. So it's just a quick email from everyone. Everyone knows my email.
Professor, I just wanted to clarify, is this what we're emailing, like our answers for this, is this what we're emailing you now?
Yeah. Yeah, but you don't have to fill in all of the boxes. Just try a couple of them. This is more for your own practice. I think if you kind of work off of this, build up the mappings here and kind of show some of the work on the side, this is probably going to be a good reference for you for the exam. You're going to be doing these number conversions for the exam.
Skip a question. Do we have to finish all of them to get the full credit, the full credit for attendance, or no?
No. Just do a handful. I don't expect you to do all of this in class. Okay, so while some of you are working on this, let me just kind of go back to looking at the one that I did on the Excel spreadsheet. So if I have the binary here, okay, so you have these base 2s here, and let's say you want to get the base 10 of these. Delete this here. So so these are all your exponents, right? So 0, 1, 2, 3, so on and so forth. You can go up however high you want to go. And then this is your 2 to your exponent, okay? So 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, and so on. So if I have the and this row, it would be your binary number. Right, so I start off with 0. So of course that's going to equal to 0 from a binary perspective. Where's my PowerPoint at? Okay, and here's my Excel. And so let's take this first number here. So the first part is 001. So 1, 2 zeros, and 1, 1, 1. Okay, so I'm just doing this like on a spreadsheet, but hopefully you can see the calculations as it's coming through. So I'm putting a 1, 1, 1, and 1. Okay, and 1 times that is 128. 1 times this is 32. 1 times 16 is 16. And then 1 times 1 is 1. And to get your total decimal number, which is 177, you just add all of these across here. All right, so that's why you hear it. See, this is a sum of all of this here. Okay, so if I were to put a number here, this would be 177. Okay, if I reset this, and let me do this one. That one like that, this will be 143. Okay, so you had the 1 times this, 1 times that, 1 times that, 1 times that, 1 times that, and then sum them together, and you have 143. Like so. Okay, so let me look at this one. So if I go back up to the hex table here, let me take a snippet of this. So this 2D, so what is 2 and a D for hexadecimal? So you have your 2 here, right? So for decimal, that also equals to 2, and for binary, that's 0010. Okay, and then your D is over here, right? So you have your D here, and that equals to 13, and it also equals to 1101, right? So let's say I want to take the 2D and 0010, 0, and what's the other one here? 2D 1101, like that. Oops. That. Right, so that's why I was saying that the easiest thing to do with the hex is just to have this mapping of all of these to either the binary or the decimal, right? And then you can do the same thing here. And likewise, you can take this and go to base 16 in the same way, right? So I can take groups of 4. So in this case, this is 1011 and 001. So this 001 is 1 here, and 1101 is right here. So that's D, right? So that would be D1, like that. Okay. So that's a quick idea of how to do like base 10, base 2, and base 16 to go back and forth. Okay. Okay. So
Wait, would you be able to repeat that real quick as to how you got D1? Because when I was doing it, I got B1.
so where's my, so here 1011 is 1011. Oh, you're right, 1011, my fault. So that's 1011. So that should be a B1. I made a mistake there. Okay, so that should be a B, you're right. Okay, and then this part is 001. So that's why you have this 1 here. Okay. So let me see here. All right, so for this one, where I took the 1001, these 4 ones here. So basically when I convert it using like these different base 2s here, wherever there's a 1, it's basically 1 times that to come up with this number here. And then wherever there's a 0, that becomes a 0 here, right? So it just kind of comes down to this main line here. This main line is where you're doing your sums here. So you do the 1 to the 128, and then zeros across all of these, and then 1s to each of these, like so. And then you're going to sum 128 to 8, 4, 2, and 1, and you will end up with 143. Okay. Okay, so I know like I'm walking through these pretty quickly here. As part of the resources, we'll actually have like a step-by-step conversion for each of these steps here. And there's a couple of different techniques to actually make these conversions. I'm just showing you one of them. With the examples that we'll provide in the resources, you can pick whichever one makes the most sense to you. Works easy for you to do it. Okay. Okay. So let me see here. So base 16. I have to do another conversion for this to base 2, and then I'll make that to base 16. Oops. See here. So 1,000 and then 0, 100. And then if I go back to here, and I can see here, that's for this group of 4 here. And then I have the here for this one here. Okay. So then I would put 84 here. Okay. All right. So I'm going to leave it at that. Like I said, I'm going to post more resources on this so you can go from any of these numbers to another number. And you don't have to fill all of this in for your email to me. You can just send it to me with whatever you have. But I would say just keep that for reference. When you do this for the exam, so what you would do is you would write whatever on your notebook, show the work that you did it. And then you would take a picture of it with your phone and upload it into the exam. So the exam will have a upload feature, and you'll be able to upload your picture into that. That will be the way you show the work that you converted from one base to another base. Okay. All right. Let's see here.
Professor,
Yes.
just a quick question. How do you convert like from base 2 to 10? Just how do you go? What did you have to do to go backwards? I like missed that.
Okay, so the idea going from base 2 to base 10 is you're basically summing up all of the different numbers. So you start off here, like you can think of it these as like your places, right? So like in your decimal system, you would have your ones place, your tens place, your hundreds place, your thousands place, right? In your binary, you have something similar like this, right? So the analogous thing for your decimals will be like this is your ones place, your tens place, your hundreds place, but in binary, it only goes up to 2, right? So that's why it only goes 0 and 1 here. And then you have like up to 2 and then 4 places, 8 places. These are how many spots you have in each of these slots here. And then each of these, if there's a 1 there, you take that down to here, and then you have to add all of these to come up with your decimal number here. Okay, so it's almost like if I have, this is in base 10, right? If I have a 9, 1 and a 9 here, right? So this is 9 ones and this is 1 10, right? So you can think of this as 10 plus 9 equals to 19. Okay, so it's the same type of concept here, except this is just base 2. So it's a little bit weird when you look at it as base 2, but if you kind of look at it, I try to draw the analogy to the base 10. Right, so like I said, this is your ones, this is your tens place. Let's say you had a 1 here, so then you would have 100 like this. So it's 100 plus 10 plus 9 equals to 119. Okay, likewise here, you take all of these numbers, add together to come up with your number here. Okay, so I know it's just like a little bit weird because it's a different base, but the idea is still kind of the same thing, right? So, you know, you kind of do this in your head when you see a number like 119, you would see 119, right? But the reality is, if you map it to like how you do it here with these conversions, you're doing 9 ones, a 10, and 100. And so then you add these together to get 119. Okay.
Thank you.
Yep. All right. So I know it's confusing for a lot of people on this, and I'm going through it fairly quickly. But I can promise you we're going to provide you a lot of examples and resources to work off of. I would just suggest to copy the examples, try to understand them. I mean, hopefully what I just said here for the decimals makes sense, right? If you look at your binaries in the same way, you know, you're basically adding all these different places together to come up with your total number. Okay. We're going to do it in recitation. We'll cover it more. It is open book. So you take these examples, there's only going to be 2 different types of conversions, right? It's binary, decimal, and hex, right? So as long as you can get those down, you know, then you should be good. Okay. So I'll give you the resources. You'll have plenty of examples to work off of. And if you're still confused or stuck with it, you know, come to my office hours or go to the TA's office hours to work it through also, right? But this is a key course objective or learning point. So you should try to understand this part here. Once you get it down, it's kind of mechanical, right? Once you understand what's going on here, you're just kind of following the mechanics on it. Okay.
I'm sorry, sir, that I still have a question on like the grades we got today. Do we have to turn in our steps on these questions, each steps to get the full credit?
No, for today, like I said, this is more just for me to get something from you that you are part of this class. You know, for you to study for, I would recommend that you write the work or show the work somewhere, because you are going to have to show the work when you do this for the exam. You can't just come up with a number magically and then put it in there for the exam. So you do have to show your work. So usually what people would do is they would write it on paper, take a picture of it, and then upload it.
Thank you, sir.
Yeah.
I appreciate it.
I just have a cool question. You know how you said we have to like write it down and everything?
Yeah.
What if we use Excel just how you did?
So if I do this, so if I can show the work like this, you know, I think that would be something that, you know, I think you should still kind of talk and explain like the mechanics behind it, but I would be fine with that.
Like, could we take a picture of the screen, like our computer screen, if we used Excel?
You can, but just like where I was talking about how, you know, what exactly are you doing, where you're taking each of these to come up with the number for that place and then adding them together to come up with your total number. If you can just explain that, then I think that would be fine.
Wait, you said you can, right? Can.
Yeah, CAN, right?
Yeah, just clarifying, thanks.
So, but you know, like I said, you have to kind of show some sort of understanding that you know, like why you're doing certain things, right? Because otherwise you can just take a generic Excel sheet with the formulas on there and just punch a number in, right?
Gotcha, yeah.
Yeah, so you can do it, but like I said, you kind of have to talk me through it or talk to TAs. The TAs will be grading your exams. Just kind of say what you're doing. You're taking, you know, let's say 2 cubed to come up with 8, and then you're adding it to all these other places, right? There will be other things where we might be adding numbers together and whatnot. So if you just go in there mechanically not understanding what's going on, you're going to have some problems, right? So we just want to make sure that you actually understand the mechanics of what you're doing. So just explain that, and I think you'll be fine.
Gotcha, thanks.
Okay. But you can see here, I'm showing the formula here, what I'm doing here. And, you know, take a picture of that and just put like a little commentary about what exactly you're doing. Okay. All right. Let me go back to here. Let's see. Okay, so these are like the highlight points that you want to try to remember, right? So presence and absence, you know, it's the whole binary thing, right? Historically, there will be things that were like punch cards that you can punch holes in them. And that's the idea of presence and absence. And essentially that translated to a binary representation. It was like machine code that they used to punch, they slide these punch cards into these big mainframes to read those zeros and ones. Okay, so you have the binary notation or binary system, the hex notation, which I said is, I look at it as just groups of 4 on the binary and you just map them across. And then, you know, so the binary with decimal numbers compared to decimal numbers. I think I kind of showed that here. Let me turn this back off again. Like I said, each of these places here is pretty much equivalent to your base 10, right? It's just that it's a much smaller number. You only have 2 numbers to work with for each place before you roll to the next one. And so what do I mean by that? So let's say I have this is my first number from a binary perspective, right? And then this is 1. Okay, now, like normally, if I have like a 9 here on a base 10, if I add 1 to it, then I basically go 1 and 0. So this 1's place basically flipped over to become 0 because I can't go any higher than 9 on base 10, right? And then I just move the number 1 over to the next column. That's how come I got 10. Likewise, if I go to here, if I add a 1 to this, what happens? I flip this over, this becomes 0, and then the 1 carries over to the next column, right? So when we talk about like binary versus decimal, the mechanics are still the same. It's just that each of these places are a smaller number compared to the number of options you have under base 10, which is obviously 10 numbers, right? 0 through 9, right? So, you know, likewise, I go to the next number here, right? Because you have like that, you add the 1 number to it, right? And if I was doing this in base 10, I would have 1 like that, 2 like that, right? Now, if I add 1 to this, again, there's only 2 numbers to work with. So this has to become 0. I carry 1 over to here, this becomes 0. And then I have to put a 1 here, right? So that's how it works. But even though it's only 2 numbers, it works the same way as your decimal places. You're just kind of not used to it because it's only 2 numbers there. And so this is what I mean by doing math, right? So if I tell you I have 0, 0, 1, and I tell you, please add 0, 0, 1, right? Then it works the same way as decimal. It should go 1, 0, 1, right? So if I add this number to this number, you get this number. Likewise, if I add one number here, then I get 1 and 3. I hope everybody followed that. That's also something you should know how to do, right? So I can add one number to another number, right? For hex, if I had a B, if I add 1 to it, it becomes a C, right? Right, so the mechanics of adding numbers are still the same. It's just a different maximum number, a different base. Okay, so I hope everybody followed that. Okay. All right, so for the question about using the chart for the conversion, yes, please show the chart and circle the mapping that you're using to do that conversion. Okay. So kind of like what I did here when I was doing it, right? I did the underline, like, so I underlined this, right? And, you know, circle it or whatever. Okay. All right. I know it's not on the PowerPoint, but this is also something you should be able to do. If I tell you to add 1 to something or whatever number, right? If I told you to add 1, whatever it is, just know the mechanics of how it works, right? So you just, whatever base system you're using, when you hit the maximum number, you roll it over to like 0, right? Assuming I only add 1, let's say. So if I add a 1 here, right, obviously it's 14, right? It's the same thing if I add 1 to here. It's just that there's only like 2 numbers to work with. That's why it becomes a 0. Okay. All right, so that's something to pay attention to. And here, like I said, ASCII, like I said, the main thing for ASCII or even extended ASCII or Unicode, it's basically translating whatever keys you have on your keyboard into what the computer would understand. Okay, either in terms of binary or hex. Okay, and it's just a table mapping. You know, if I summed it, it would be like ASCII is what we started off with, but then we want to cover more characters. That's how you ended up with extended ASCII. And then Unicode basically went into things that were non-English type of language to do the mapping. So it became more global, I guess, by using Unicode. Okay. So the PowerPoint didn't talk about metadata, I think, but I will tell you metadata, for those of you that maybe take photographs and stuff like that, you can imagine like when you look at some of the metadata for that, it might, or whatever, but I'm just giving an example for photographs. You know, metadata is information about information. So in this case, if you're talking about a picture, you might talk about like, oh, where did I take the picture at? You know, what was like the resolution of the picture? What camera did I use to take that picture? You know, different types of information that's above and beyond. It tells us more about the picture that we took, let's say. So that's an example of metadata, but the idea of metadata is basically information about information, okay, about the information that you took. It could talk about the version, right? Maybe you're working with the latest version of a picture. How many megs is it? Whatever, like the location and whatnot. So that's what metadata is all about. And you have a lot of that, especially now when you get into like the Internet of Things. There's all kinds of information floating around, but unless you tell us what that information is about, it kind of doesn't mean anything. So having the metadata is important so that other things know how to use that data. Okay. All right, cool. So it was 2 hours. Yeah, I know we tried to cover a lot, but hopefully we have enough for you to go on here. I'll be posting these slides out there. onto the week 1 resources, and we'll have places for you to go and look and practice more of these. Send me any questions if there's anything that you'd like to know that I didn't cover. Okay, so with that, I leave you guys. Have a good night, and thank you for the first class.
Thank you very much, Professor.
Thank
Okay.
you.
All right, good night.
Thank you, Professor.
Thank you so much.
Thank you.
Thanks.